We'll start with a review of right angle triangles. So we know that when we have a right angle triangle, meaning that we have a 90-degree angle in our triangle, we can use one of the following things. So either Pythagorean theorem, so remember that c squared equals a squared plus b squared, where c will be the hypotenuse or the opposite of the 90-degree angle. Or if you're dealing with angles, you can use trig ratios. So sine of whatever angle you're looking at is opposite over hypotenuse, cosine of whatever angle is adjacent over hypotenuse, and tangent of your angle is adjacent over opposite. So this is where we get the SOHCAHTOA. So for example, let's review right angle triangle theory and solve the triangle below. Anytime you see the word solve, it means find all the missing angle measurements and all the side legs. So here we have a 90-degree angle. So we have a right angle triangle, which means we can apply Pythagorean theorem and we can apply the primary trig ratios given in SOHCAHTOA. So let's start with our labeling. So I'm going to label this triangle A, B, and C. C is generally always opposite to the 90-degree angle, so that would be our hypotenuse will be the 5 yards. So the first thing I'm going to do is use Pythagorean theorem to find my side B on the other side. So let's find side B first, and we're going to use Pythagorean theorem. So we know that c squared equals a squared plus b squared. And if we want to solve for b, it's the altered version. So b is equal to the square root of c squared minus a squared. So substituting in our values, we have c is the opposite of our 90-degree angle, 5 squared minus 4 squared. So 25 minus 16 gives me the square root of 9, which tells me that b is equal to 3 yards. Next, let's deal with the angle side of things. So let's start with angle A. So angle A. So we can't use Pythagorean theorem, so our options for finding angles is using SOHCAHTOA. So we have to decide what we have and what we want. So I'm going to ignore that we've already solved for B, and I'm going to use the values that we have given in the question. So if the angle A is what I care about, that's my reference angle. I have my opposite value, and I have my hypotenuse value. So which one involves opposite and hypotenuse will be sine. So then I can write down my formula for sine. So sine of my angle is opposite over hypotenuse. So substituting in my values, sine of angle A, my opposite value is 4 and my hypotenuse value is 5. And then recall, in order to get sine to the other side or to find an angle or something, you're doing the inverse or the opposite of it. So A is equal to the sine, the -1 or inverse sine of 4 over 5. Please make sure that your calculator is in degree mode or else it won't work out for you. So you should be able to put in your inverse sine, 4 over 5, close your bracket, or do the division first and then inverse sine after the fact. Either way that you do it, you should get an angle of 53.1 degrees to 1 decimal place. Angle B is the last one that we have to do. So I'm going to sort of redraw my triangle or take a look at my triangle a little bit differently because opposite and hypotenuse will change depending on what angle you're looking at. So now if we care about angle B, we have the adjacent side, which is 4, and we still have the hypotenuse side, which is 5. So I still want to think about SOHCAHTOA, but now I'm actually going to use cosine in this case. So angle B, SOHCAHTOA, I actually want to use adjacent and hypotenuse, so I'm going to use cosine. So cosine of my angle is adjacent over hypotenuse. So cosine, in this case of angle B, adjacent is 4, hypotenuse is 5. And we do the exact same thing. So cutting off the cosine and making an angle representation, we're going to use cosine inverse. And again, checking to make sure that your calculator is on degree mode, you should end up getting 36.9 degrees, again, to 1 decimal place. Notice you can also think about a sum of all angles. So in a right angle triangle situation, the other two should add up to 90 degrees. So it's always a really good check to do because we know that all the angles in a triangle should add up to 180 degrees. So it's important to make sure that we're thinking about checking our work at the end of it.